on this computer, and then I'm going to share a screen. Okay, so last class, I remember we discussed stack. So I'm not sure if you guys still remember the major principle, or we call it a major manner of stack, the 4 letters. Do you still remember, or who still remember that? And so we have the stack, is it? So for stack, do you still remember, like, where can we access? So is it we can only access at the top, is it? And what do we call, we add a new item? Do you still remember? We call it what? We call it push, is it? And whenever you want to remove, you can also just remove from the top. So we call that operation of pop, is it? So the feature for stack is what? Is LIFO. So that's a major feature, okay? And the last class, what we discussed about our stack is a bounded one. So we have the bounded one. So then in that implementation, we have stack is full exception that we deal with it. And today we will start with the stack that's unbounded. So today we are going to discuss with unbounded capacity. Okay, so let's see. And also implemented it in array. Okay, so let's see how do we handle all of this. Okay, so let's see. So most of the stack part, this stack integer, are pretty similar as what we discussed last week as the last example, okay? So we still have the integer array as one of the instance variable. The second instance variable is the top index. And we still set the constant capacity, okay? So nothing new here. For the default constructor, nothing new. So we create the array with new int. And we set the top index to -1. And for the second constructor, the explicit value one, this time we change. For this one, we're just going to create an array with the specified capacity, okay? And the top index is still set to -1. So then this indicates that our stack is an empty stack. So in both cases, the default one and the explicit one both create empty stack. So for the second one, it's a little bit different from what we discussed last class, okay? And we also know the empty function, just check if your stack is empty, you just check if the index is -1. So the major thing changes this time is for our push operation, okay? Because this time we said our stack is unbounded. So it won't report stack is full exception, even though it reaches the initial array's capacity, okay? So let's see how do we deal with this. So as usual, whenever you want to add a new item, the top index is going to be incremented by 1, is it? So nothing changes here. But if your top index, in this case, we do the check. If it's greater or equal than your initial array's size, the capacity, is it? Then what here we are going to do is we are going to create a temporary array. And this temporary array, the size is going to be double size of your first array, the first time you create the stack. So basically this array, this temp array is going to be twice as deep as your first stack. And then what we can do is for array, you can do array copy, and this is a deep copy, okay? So you just call the system.array copy function, the method, and then you can copy whatever in the initial array to this temporary array. And then you reset our initial array, let it reference to this newly created array. Okay, and then you add that new item to this newly created array, basically. Okay, so in this case, so initially you have a stack size like this. Is it? That's the initial one. Initial one. And because it's full, so here, it's full. Is it? Then what we did is you double the size. You double the size kind of like you create another array that's twice as deep as the first one. Is it? So temp is initialized here. And then you set your stacks array, let it point to this newly created one. That's it. Then basically you abandon the initial, the first time that array you created. Is it? So then in this case, we don't need to worry. We don't need to worry the full condition for our stack. Okay, so that's a major change in this version. And then for pop operation, nothing new here, is it? But we still with, if the stack is already empty, then you don't have anything to pop, is it? So that's why we still deal with it with the exception. And for the top function, it's similar as what we already discussed the last time. So whenever it's empty, then you throw that exception, okay? And for the toString method, it's also similar as what we already discussed the last time. So we are going to output all of the contents of the stack from top to bottom, okay? And we also have the deep copy of our stack. So this clone is a deep copy one. So this is our second version of the integer stack class. And this time, this integer stack class, it's capacity. So it doesn't have capacity limitation. So it's unbounded one, okay? And then let's take a look at the driver part. For the driver part, what here we are going to discuss, about the application is, so for stack, last time in our last discussion, we said that stack is convenient whenever you want to reverse a collection of items. If you want to reverse a collection of items, we can use stack. And today we are going to learn another application, is you can use a stack to convert a different base of number. And here we are going to discuss convert different base of integer. Suppose you have decimal number, is it? And you want to know what its binary format number is, or what its octal, or what its hexadecimal format is it? So how do we do that? And we have an algorithm. We can do base conversion among them. And the algorithms looks like this. Okay, so suppose here we have a decimal number, 13. So this is a decimal number. Okay, decimal. And you want to convert it to binary. To binary. So binary means only have 0 or 1. Is it 0 or 1? So how do we do that? We can use a stack. Okay, so let's see. So here you have a stack. And this stack, we are going to use our, so in our code, you can see we're going to use our integer stack that we created. Is it? So what we can do is, so you use the 13, is it? And use 13 to divide by 2 because this is binary. So you divide by the base. Okay, and what we are going to get, this is going to be integer division. So you get 6, is it? And then we also do the module of the base. And what we get here is 1, is it? And you're going to push that remainder to the stack. And the next, we are going to use the divisor to divide by 2 again. So what do we get? We get integer 3, is it? And you use that divisor to do module 2. What do we get? We get 0, is it? Then you can add this 0 to the stack. And we can continue like this. So then it's 3 divided by 2. Okay, it's do the integer division. So we get 1. And when you do 3 module 2, what do we get? We get 1, is it? So you're going to push this 1 to the stack. And next, you do that 1 divided by 2, we get 0, is it? And then 1 module 2, we get 1. And with this remainder, we are going to add to our stack. It's 1. And over here, when you continue repeatedly do the division of your base, and you get 0, is it? When you get 0, that means you need to stop. Okay, we can stop our loop. After we stop our loop, then you just pop all of the items out of the stack. What do we get? You get 1, 1, 0, 1. Is it? So this 1, 1, 0, 1, this is the binary number of decimal number 13. Okay, so over here you see we use a stack to store all of the remainders of your repetitive division. Okay, and then you get all of the items out, and then Z consists of the corresponding base number. Okay, then let's take a look at this method. So this convert to base. And here we deal with not, so the example I just explained is convert a decimal number to base 2. Okay, so it's a binary conversion. Okay, and in this method, we are not just going to deal with base 2. You can also deal with other base. Okay, like octal or hexadecimal, is it? So the algorithm is, the first part is you're going to repetitively do the division, is it? Repeatedly do the division until the remainder is 0, is it? And whatever you push to the stack is you do the module with the base. And you push it to the stack. And to get the corresponding, the base number of the corresponding decimal number, what you can do is you just using the while loop and get all of the items out. Is it get all of the items out? So you keep calling pop operation, and whatever on the top, you're going to add it to your base. And if the base is greater than 9, is it? So here that means the top, if the top number is greater than 9, because the number we only, the digit we only have 0 to 9. Is it? So if your top is greater than the 9, what we can do is we can do the conversion. Okay, we can do the conversion, because like for hexadecimal number is also support A, B, C, D, E, F. So that's why here you can convert it to a corresponding character letter to represent it. So that's what this method does. Okay, so convert to a corresponding number. And then over here, what we try to convert is we first try 1001, convert it to base 2. And then next we try this 1001 converted to base 8. And what next we did is convert this 1001 converted to base 10. And the last one is convert 1001 converted to base 16. Okay, and we can run this program and see the result. So you can see this is a binary format, is it? And like I previously explained, binary is only support 0 and 1. So in this result, you only see 0 and 1. For the octal, so it's base 8, is it? So base 8 only support a number from 0 to 7, is it? That's why the result, you only have 0 to 7, is it? And the next one is decimal to decimal itself, is it? So it's base 10. So you have from 0 to 9. And the last one is hexadecimal. Hexadecimal is base 16, is it? That's why in the output, is it, we see you have some letters, is it 3E9, is it? But basically this represents the decimal number 1001. Okay, so this is base 16. And the second part of this program is try to do a search. So how do we search an item in our stack? Is it? And in this case, we don't want our stack got modified. We don't want our stack got modified by this, by our stack operation, is it? So within this method, what we did, the very first step is you call our stacks clone method. So we call the clone method. So we create a deep copy of our stack, is it? So then all of your pop operation is going to be on the copy one, not the original one. So the idea here is, so this is the original one. Okay, and you call the clone. And then we have the copy. So this is the stack clone. It's a copy. So all of your pop and so all of the operation push and pop, this going to be on this clone one, not on the original one. So that's why the original one won't be impacted. Okay, so let's see, how do we do the search? Is it? So when we do the search, so we need to keep check if your top item is that integer number you're going to look for, is it? If you find it, then you return. So it's a stop, keep looking for the number. Otherwise, it will remove the top item and then check the next item, is it? So in stack, we use this kind of while loop a lot. So you have the while loop, and the loop termination condition is the empty. the stack is empty. And within the loop, you keep call the pop operation, okay? And you use its top to check if the top item is something that you are looking for, okay? Okay, so that's a search method. And over here, we create an integer stack with number from 0 to 9, is it? Then we try to find if 8 is in the stack, is it? And we just also run our program, and it's returned, yeah, it did find the item. Okay, so that's the first part of this class.